All right, everybody, this is an overview for Lab 5. Lab 5 is meant to demonstrate how we would run an independent samples t-test using Excel. So we have a counterpart to this, which is our next lab, which will be doing this in SPSS. But here, our goals are to be able to enter data into Excel and use it to calculate a t-test. So let's go ahead and give it a go. So you'll start by opening a blank workbook like I have here. I have already started inputting my data. So you will have all of this data in your spreadsheet like so. Notice that I've left column A empty because we're going to include some calculations or labels for our calculations over there. So just be mindful of that. So here we have our situation, our circumstance. So this is similar to the origin of the t-test, which was created by, remember, a head brewer at Guinness who was trying to determine if one field of crops was more productive than the other. He did so using a very simple statistic, what we call the t-statistic. So the first thing that we'll do is in column E, all right, remember column E over here, we're going to write out null and alternative hypotheses for this particular situation. So you would just have them over here, right? You can just label them like so. All right, I'll leave this to you to do, but the idea, of course, is that the null would be that there's no difference between fields. The alternative would be that maybe there is, right? So I'll go ahead and put those over here. And the first thing you'll do is calculate means for each of these. So means are important to doing an independent samples t-test. Remember that independent means that these values do not impact each other. So the production of field 1 isn't impacting the production of field 2 and vice versa. So we'll want to calculate means for these. So remember, you're going to have more data than this. So your means are going to be a little further down here, but I will still show you how we would want to do this, right? So remember, we can do an equals average, and then it's going to ask us what values we want to be included in that average. So you can either manually say, okay, we want from cell B2 all the way to cell, what, in my case, B9. Again, for you, it'll be different, and it highlights the values, and if I press enter, it will give me an average. And then I would want to say label it over here. Another way I can do this, if I type in equals average here, it's asking me what values to include. I can just highlight which values to include, press enter, and it will do the same thing for me here. So you'll go ahead and do that for both columns. And we'll also do standard deviation. Standard deviation is the very same way. You click standard deviation, include the values that you want in that calculation, and you will get a standard deviation. So remember, you're not looking out for my values here, you're looking out for values that would be more indicative of the full data set. Then we calculate variance using a slightly different technique here. So remember that standard deviation is the square root of variance. So we would have this labeled here. All right, and then if we want to get variance as well, because remember, variance is actually part of the t-test formula. If we want to get variance, we would do something like take our standard deviation value and square it, which we do the following way by using this caret and a 2. And there we have it. We have variance calculated very quickly for us here. We also want to conduct a count in order to get our sample size. So if we do an equals count and have it count up our values here, in my case, I only have half the data. Yours should be a bit different than this. But of course, we will just label them all using that column A that we left available. Then you will manually calculate a t-value using this formula. So you'll calculate your means, calculate your variance, and get your sample size. Then go ahead and calculate this and get a t-value and include that here on your spreadsheet. All right, so we're going to test at an alpha level of 0.05. So this is like our homeworks and like the examples we gave in the t-test lecture. We're going to be using that same formula, those same cutoff criteria to answer a couple questions here. You'll answer those questions just somewhere over here, right? Just somewhere where they're not in the way of the rest of your work. So I'll leave this to you, right? Is there a statistically significant difference between these based on your calculations? Which has a higher yield? And what if we tested at a different alpha level? So then the next piece is that we'll actually calculate a t-value. We'll do a t-test. All right, a t-test. So what this is going to do is compare All right, let me go ahead and get this running here. This is going to compare two sets of data as an independent samples t-test does. So we're going to give it two arrays of data to use, in this case field 1 and field 2's yield. Then we're going to tell it a few other things. So I'm first going to give it yield, or the field 1 for the first array. Then it tells me to put in a comma for the next array. All right, so again, you can manually put these values in, and I have the details in the instructions over here. But we want to make sure that we're highlighting this data, right? All the data for field 1, all the data for field 2. Then it's going to ask us how many tails are in this test. Remember, how do we dictate whether this is a one or a two-tailed test? Well, this is two-tailed because we're comparing each of the fields to each other. We're not predicting that one is higher than the other. Then it's asking us for the type of t-test we want to run, and since this is an independent samples t-test and of equal variance, we're going to select 2 here. We can go ahead and run this, and it's going to give us a p-value. So again, yours will be different than this, but it's going to give you a p-value or a probability. So if this value is less than 0.05, then we have statistical significance. If it's not, like mine here is barely not, that would mean that we don't have statistical significance and that we have evidence that the null is true. So there we have it. I kind of breezed through these pieces, but that's what we need to do with all of the data. Then of course you'll have answers to your 3 questions here. So as always, please be in touch if you have any questions on this assignment.